Number 1 asks us to write a sequence of rigid motions that will take figure ABC onto DEF. So this was our work with zigzags. So we know if we can get 2 points lined up that the third is going to fall into place as well. So when we're doing this, we will just want to get these touching. So we're going to want to translate figure ABC by directed line segment and whatever you want to connect. I'm going to go A to D. So by directed line segment AD. Then we will rotate the image of ABC until, we'll rotate the image of ABC until the image of B coincides with E. So we're going to take this, we're going to move it over here so that A lands on D. Then we're going to rotate that image until the image of B lands on E, and then everything lines up. Number 2, prove that these two circles are congruent. So prove that circle A and circle C are congruent, and they tell us here that the length of AB equals the length of CD. So we know that segments AB and CD have the same length. So that means they are congruent to one another. I'm going to make this a little bit smaller here. And the reason it's important that we know that they are congruent to each other is then we know that there's a rigid motion that will take one to the next. So if these are congruent, therefore there is a rigid motion that will bring AB to CD. So we will apply that rigid motion. So now we've gotten segment AB onto CD. Then we know the definition of a circle says that it is the set of all points equidistant from a given center. So that means that one circle's center and radius. So now if we know that it's the circle is the set of all points equidistant from the center, and we know that these two radii are the same. So that means that one circle's center and radii are going to coincide with the other circle's center and radii. Then therefore we get all of the points will land on the other one, and meaning that they're congruent. Number 3, which conjecture is possible to prove? And so to prove that it's true, so A says all quadrilaterals with at least one side length of 3 are congruent. So every quadrilateral that has a side length of 3 are congruent is what this is saying, and that's false, because this could be 3 and then these could be all sorts of other things, and we could have something like this with this one being 3 and this, and those are clearly not congruent. So that's called a counterexample to show that that's not true. All rectangles with at least one side length of 3 are congruent. So we could have something like this where this side is 3, so we would know this one is, but that doesn't mean that it's going to be equal to the others, because we could have this with 3 here. So these two would be 3, but these could be 4 and these could be 1. So that's false. All rhombuses with at least one side length of 3 are congruent. So now we know all of the sides are going to be 3. So every single side here is 3. But rhombuses don't have set angles. So it could, let me try and make one that looks fairly different than that. So like this could be a much skinnier angle at the top. and all still have 3 side lengths, but definitely not congruent rhombuses. So this one must be true. All squares with at least 1 side length of 3 are congruent, and this is true. And we would know that because a square has set angles. So all of the angles in the square are 90, and then all of the sides are the same. So all of these are 3, and all the angles are the same. And so if you draw another square, it's going to have 90-degree angles. And if one of the sides has to be a 3, then all of the sides have to be a 3 since it's a square. So D would be true. We would be able to prove that one. Number 4, match each statement with using only the information shown in the pair of congruent triangles. So which pair of triangles, 1, 2, or 3, shows 2 sides and the included angle of one triangle is congruent to 2 sides and the included angle of another triangle. So we want to see 2 sides marked. And so we see that down here, number 3, 2 sides, included angle, 2 sides, included angle. So this one is number 3. B says 2 angles and the included side. So we're looking for 2 angles and the included side in one triangle. So 2 angles and the included side in one triangle, congruent to 2 angles and the included side in another. That's represented in diagram number 1. And then C has 2 triangles where there are 3 pairs of congruent sides, and we see that in number 2. Number 5, triangle HEF is the image of triangle HGF after a reflection across the line FH. So we've got a reflection here, and it just says write a congruent statement for the 2 triangles. So since they're saying these are images of each other, they must be congruent. So you could just kind of steal that and just put triangle HEF is congruent to triangle HGF. So that's one way to do it. You could just kind of steal it. You could also go to the picture and do it in a different order if you wanted. So if you wanted to go FHE, you could do that. So FHE is congruent to, and then just follow the same order on the other side. So FHG. Or there's some other options too for you, but there's 2. Number 6, triangle ABC is congruent to triangle EDF. So Lynn knows there's a sequence of rigid motions that takes ABC to EDF. Select all true statements after the transformation. So I'm just going to write these 2 congruent triangles out a little bigger. So we've got ABC and then we've got EDF. And I'm just going to line them up with each other so we can kind of see the corresponding sides a little easier. So A says that A is going to coincide with F, and that's false because A is going to coincide with E. B is going to coincide with D. That's true. C is going to coincide with E. That's false. And I like to do it this way because these triangles look pretty similar. They'd be easy to kind of screw up if you're going by looks. So when they tell us which 2 triangles are congruent, it's nice to look at the order of those letters. Segment BA, so these first 2 letters, is congruent to segment FE, which is the first and the last. So that's going to be false. And then segment BC, so the last 2 letters, is going to be is going to coincide with FE. Oh, whoops, I read that one wrong on the last one. I read this one instead of this. Okay, so let's look at D again. So BA with DE. Okay, first 2 and first 2. So this one is actually true. And then this one, BC, coincides with FE. So BC is these last 2, and then FE is the first and last. So that one's going to be false. Sorry about that. And then number 7, this design began from the construction of a regular hexagon, so we know all the sides and angles are the same, is quadrilateral JKLO, so this shaded quadrilateral here, is this congruent to the other 2 quadrilaterals? So is it congruent to this one and this one is what they're asking us. Okay, and that's yes, it is. Okay, so yes, JKLO is congruent to the other two quadrilaterals because rotating JKLO by 120 degrees and 240 degrees around center O. So this kind of point right here, right in the middle. Okay, let's fix this. Around center O will produce the other two quadrilaterals. Meaning they are congruent.